Okay, we know about indeterminate forms. 0 by 0, we have infinity by infinity, we have 0 times infinity, we have infinity minus infinity, we have 0 to the power of 0, we have 1 to the power of infinity, and we have 0 infinity to the power of 0. Okay, so many times what happens when we are trying to solve problems, we end up with this form of limit problems where direct methods lead to these type of forms. So how to solve those type of problems? That is where we use L'Hopital's rule. Let's actually solve problems and learn how to do that. So first problem is a limit as x approaches 1 of 2 natural log of x square by x square minus 1. Now let's actually do direct substitution and see what happens. We get 2 natural log of 1 square divided by 1 square minus 1, which is 2 times natural log of 1 by 1 minus 1, which gives us, now natural log of 1 is 0, so 2 times 0 is 0 by 0. So we are stuck. That doesn't mean limit doesn't exist. So we need to use the L'Hopital's rule. So here what we'll do is, once we are able to arrive at this type of form, here directly we know it is in that form, we can differentiate both the numerator and the denominator independently. So so ideally what I should write is split this limit into two limits. 2 natural log of x square divided by the second limit, 1 of x square minus 1. So if we split this, now we differentiate. Remember, we don't apply quotient rule here. So this, when we differentiate, we get as x approaches 1 of 2 times 1 by x square times 2x divided by limit as x approaches 1 of 2x. Right? One of the x's cancel here, and let's see then what happens. We get limit as x approaches 1 of 4 by x divided by 2x, which can be written as limit as x approaches 1 of 4 by 2x square. Now, when we actually take the limit, we get 4 by 2 times 1 square, which is 4 by 2, which is, so limit of this is 2. Okay, now let's look at the second one. Limit as x approaches 0 of 5x by tan 3x. Direct substitution will give us what? 0 by tan 3x can be written as, this becomes actually tan 0. Tan 0 is sine 0 by cos 0. Cos 0 is 1, but numerator is sine 0, which is 0. So we get 0 by 0. Okay. So now we again split this limit as x approaches 0 and we differentiate it. Now every time I'm not going to write the limit statement separately. I'll keep doing it here itself. So I'm differentiating 5 by tan x is sec square 3x times 3. So which gives us as x approaches 0 of 5 by 3 times 1 by sine, no, sec is cos square 3x. Now see what happens. We get limit as x approaches 0 of 5 by 3 times this, we can say multiplied by cos square x. So cos square 3x. Now when we actually take the limit, we get pi by 3, 3x substituted 0, we get cos square 0, cos 0 is 1, so times 1 which is pi by 3. This is the limit. Okay, third one, limit as x approaches 0 from the positive side of 2 natural log of sin x divided by natural log of tan x. In this case, what happens when we do direct substitution? From the positive side, let's take it to 0. So 2 natural log of sin 0 by natural log of tan 0. Sin 0 is 0, natural log of 0 is minus infinity, times 2 will be minus infinity. And here again, sin 0 by cos 0, cos 0 is 1, sin 0 is 0, so natural log of 0 is minus infinity, which gives us infinity by infinity. Okay, so again we will have to apply L'Hopital's. So which means we differentiate both the numerator and the denominator independent of each other. We don't apply the quotient rule or anything like that. So 2 times 1 by sin x to differentiate natural log, and then sin x is cos x by 1 by tan x times, and tan x is sec square x. Now once we applied this rule, we keep proceeding to simplify it. So this gives us cos x by sin x is cot x by this will be 1 by tan x is cot x times sec square x. Limit as x approaches 0 from the positive side of cot x and cot x cancels, and sec square x is nothing but 1 by cos square x. So which means it will come up cos square x, and this we do direct substitution. 2 times cos 0 is 1, so 1 square is 1, so which is 2 is the limit. Okay, fourth one, limit as x approaches infinity of 2x by e to the power of x. Again, directly substituting it, we get 2 times infinity, which is infinity, by e is a constant, but anything taken to the power of infinity is infinity. So which means again it is, we can apply L'Hopital's rule. So we differentiate both numerator and denominator independently. So 2 by e to the power of x. That is what we get if we differentiate e to the power of x. And now when we take the limit, we get 2 by infinity, which is equal to 0. Okay, fifth one, limit as x approaches 0 from the positive side of e to the power of 2x by sin x. Again, do the direct substitution, you get e to the power of 0 by sin 0, which gives us 1 by sin 0 is 0, right? This is it is not any particular indeterminate form. So we can't use this itself. So which means we can't apply the L'Hopital. But what we can do is limit as x approaches 0 from the positive side of 1 by sin x, right? And this e to the power of 2x, we take it down 1 by e to the power of 2x. If you simplify this, you will get this. Okay. So now, when we take the limit, what do we get? 1 by 0 to the limit, if we take, we get infinity. And 1 by e to the power of 2x will take us to 1. which means the limit is. So here if you notice, did we really apply the L'Hopital's rule? No. Okay. But we still arrived at the limit using some other method. Sixth one, limit as x approaches 0 from the positive side of 5 natural log of cos x by natural log of tan x. Now this 5 we can take it out and put the limit in. So limit as x approaches 0 from the positive side of natural log of cos x by natural log of tan x. Here again, if we do direct substitution, we get 5 natural log of cos 0. Cos 0 is 1 divided by natural log of tan 0 is 0, which gives us 0. Natural log of 1 is 0 divided by infinity. And this itself is going to be equal to 0. 0 divided by anything is 0. So which means we it is, and moreover it is not one of the indeterminate forms. So which means this direct substitution itself will work 5 times 0, which is equal to 0. So 0 is the limit. Let's look at the seventh one. Okay, this is limit as x approaches 0 from the positive side of 3x square natural log of x. Now, if we directly substitute it, we get 0 times natural log of 0 is minus infinity. So it is one of the indeterminate forms. So let's play around with this. What can we do in this case? First of all, let's take 3 out. So limit as x approaches 0 from the positive side of x square natural log of x. Now let's take the x square to the bottom. Now how do we take it to the bottom without changing the value? So what we'll do is we'll take it 1 by x square. So if you simplify this, you will get back this. Now, if you do substitution now, what happens? Natural log of x is minus infinity, that is 0, divided by 1 by x square is going to be again infinity. So again it is infinity by infinity. So which means we can apply the L'Hopital rule. Okay. Now what do we do now? Which means we are going to differentiate the numerator and denominator. So let's do that. Natural log of x is 1 by x, and 1 by x square is going to be minus 2 by x cube, right? And this I will rewrite it so that we don't make a mistake. 1 by x divided by minus 2 by x cube. So that means reciprocal of that, x cube by minus 2. Now what happens? This x and one of the x's gets cancelled, and we end up with 3 limit as x approaches 0 from the positive side of x square by minus 2. Now if we do the direct substitution, what do we get? 0 by minus 2, which is 0. Let's take the eighth one. Limit as x approaches 1 of 1 by x minus 1 minus 1 by natural log of x. Okay. If we do direct substitution, what do we get? 1 by 1 minus 1 by natural log of 1 is 0, which gives us infinity minus infinity, which is again an indeterminate form. So, which means we have to manipulate this in some way. So, limit as x approaches 1 of, let's take the LCM, x minus 1 natural log of x. This becomes natural log of x minus x plus 1. Now limit as x approaches 1 of, what do we do here? We will differentiate. Okay, so it is in the indeterminate form, so we need to differentiate it to apply the L'Hopital's rule. So natural log of x is 1 by x minus 1 by, and here what do we do? Chain rule in the denominator. So 1 times natural log of x plus x minus 1 as it is, and 1 by x. Let's simplify this. Limit as x approaches 1 of 1 minus x by x divided by, let me write it in this way. What do I get? Divided by natural log of x plus x minus 1 by x. Okay. Now limit as x approaches 1 of 1 minus x by x divided by, and this becomes x natural log of x plus x minus 1 divided by x, right? So now let's see what happens. X approaches 1 of 1 minus x by x times x by natural log of x not natural log of x plus x minus 1. So x and x gets cancelled, and we end up with the limit as x approaches 1 of 1 minus x by x natural log of x plus x minus 1. So do the substitution. What do we get? 1 minus 1, 0 in the numerator. And here what happens? X is 1, natural log of x 1 is 0 plus 1 minus 1. So we get into this form. So which is again an indeterminate. That means we can again apply L'Hopital's rule. So applying L'Hopital's rule means differentiating the numerator and denominator. See, you can keep applying the L'Hopital's rule multiple times. So this would be minus 1. I'm differentiating the numerator. Now I'm going to differentiate the denominator. So here chain rule. So 1 times natural log of x plus x times 1 by x plus 1. Now let's see, limit as x approaches 1 of minus 1 by x, and x gets cancelled. We end up with natural log of x plus 2. And now I'm going to take the limit. Let's see what happens. Minus 1 by natural log of 1 is 0. That's not a problem because we have 2 also. So which means minus 1 by 0 plus 2, which is equal to minus 1 by 2. So this is the limit. Ninth one, a very interesting ones. Limit as x approaches 0 of pi by x minus pi by e to the power of x minus 1. Yes. So here 5 and 5 is common, so we can take that out. Limit as x approaches 0 of 1 by x minus 1 by e to the power of x minus 1. Now let's apply the limit and see what happens. We get 1 by 0, that is infinity, minus 1 by e to the power of x. E to the power of 0 is 1, 1 minus 1 is 0, right? So 1 by 0 is again so again an indeterminate form. Okay, now let's see what can be done. Let's first make sure that we put it in the proper form. Let's combine them. So x times e to the power of x minus 1, and here we get e to the power of x minus 1 minus x. And now, because of this infinity by infinity minus infinity, let's differentiate this limit as x approaches 0 of derivative of e to the power of x is e to the power of x. Minus 1 is 0, minus x is minus 1, divided by, now we have to differentiate the denominator. And here we have to apply the chain rule for the denominator. So derivative of x is 1, and this part remains as it is, plus x times derivative of e to the power of x minus 1. That will be e to the power of x. Okay. 5. Limit as x approaches 0 of, what do we do now? We ignore this bracket, right? Then what happens? E to the power of x, e to the power of x is common. So let's take it out. What do we get? We get e to the power of x 1 plus x minus 1. And in the numerator, I missed it. E to the power of x minus 1. Okay. So now, if we do the substitution, now what happens? E to the power of 0 is 1. 1 minus 1 is 0. E to the power of 0 is 1. 1 plus 0 is 1, minus 1 is 0. So we end up with 0 by 0 again. So what do we do? Again we apply L'Hopital's rule. So limit as x approaches 0. We need to differentiate it once more. So e to the power of x, again we have to apply chain rule here. So e to the power of x times derivative of this is 1 plus, I'm doing it, in the other order, doesn't matter because this is plus. So e to the power of x times x, but the derivative of 1 plus x, no, e to the power of x is e to the power of x times 1 plus x. Now let's simplify this. 5. Limit as x approaches 0 of, now e to the power of x is common again. So e to the power of x by e to the power of x times 1 plus 1 plus x, right? So this and this cancels. And now if we take the limit, what do we get? We get 1 by 1 plus 1 plus 0, which gives us 5 by 2. So that is the limit. Okay. 10th one. Limit as x approaches infinity, 2x square times e to the power of minus x. So first thing we should do is rearrange it so that we don't have a negative exponent. So 2x square by e to the power of x. Through direct substitution, what happens? The numerator becomes infinity and the denominator also becomes infinity. So indeterminate form, which means we can apply the L'Hopital's rule. So let's differentiate 4x by e to the power of x. Okay. Now if we do the substitution, again we end up with infinity by infinity. So which means again we can apply L'Hopital's rule. So 4 by e to the power of x. Now what happens? In the numerator we have 4. Denominator goes to infinity. So 4 divided by infinity will give us 0. Okay. 11th one. Limit as x approaches 0 of 1 by sine x minus 1 by x. Again, direct substitution, what do we get? 1 by sine 0 is 0 minus 1 by 0, which is nothing but infinity minus infinity. So it's a indeterminate. So let's, manipulate this expression. So x minus sine x by x sine x. This is what we get. And now if we do the substitution, what happens? 0 minus 0, that is 0. And in the denominator also we have 0. So this becomes 0 by 0. Okay. Now limit as x approaches 0. Now we are going to differentiate both the numerator and the denominator. 1 minus cos x divided by chain rule in the denominator. So 1 times sine x plus x cos x. Okay. Now if we do the substitution model, cos 0 is 1, 1 minus 1 is 0. So numerator is 0. Now here sine 0 is 0, cos 0 is 1, but this x is 0. So it becomes 0 by 0. So which means again let's apply the L'Hopital's rule. So again we differentiate. We get what? Minus sine x divided by cos x. When we differentiate, okay, let's do this. Chain rule here. So 1 times cos x plus x minus sine x. So this will become minus sine x, right? Let's simplify this. As x approaches 0 of sine x divided by, so here we have cos x plus cos x. See, this is, I have removed this and put minus. So this becomes 2 cos x minus x sine x. Okay. Now what happens if we do direct substitution? Sine 0 is 0. But what happens in the denominator? We get 2 cos 0 is 1. So 2 minus 0. So in the denominator we don't have 0. So that means we can, so numerator, take the limit 0 divided by 2, which is equal to 0. So the limit is 0. 12th one. Limit as x approaches 0 of 3 cosec x minus 3 cot x. 3 is common to both, so let's take it out and put it outside the limit. So limit as x approaches 0 of cosec x, let's write it as 1 by sine x minus cot x is cos x by sine x. Now if we do direct substitution, what do we get? 1 by 0, and cos x is again 1 and sin x is 0. So this is infinity minus infinity. So indeterminate form. That means we can apply the L'Hopital's rule. But before we do that, let's simplify this. This becomes 1 minus cos x by sin x, because we are taking this LCM. Okay. Now let's do the differentiation. So limit as x approaches 0 of differentiating the numerator separately, we get minus sine x divided by cos x, right? Which gives us 3 times limit as x approaches 0 of sine x by cos x. And now if we take the limit, what happens? Sine 0 becomes 0, cos 0 is 1. So we get 3 times 0 by 1, which is equal to 0. 13th one. Now this is a little bit more challenging. So limit as x approaches 0 from the positive side of 3 sine x to the power of tan x. Now we can always take 3 out. So limit as x approaches 0 of sine x to the power of tan x. Now if we do direct substitution, what happens? Sine 0 is 0 and tan 0 is going to be 0. So we are ending up with an indeterminate form. Okay. Now somehow we have to bring this tan down. So how can we do that? Let's use a trick. Let's do exponentiation and then natural log. What happens? They cancel out each other. So we can write this as like this. Now, which means, now here what we can do is logarithm rules says that we can do something like this. The exponent we can bring it in front of natural log. So tan x natural log of sin x. Now, remember E is a constant. So what we'll do is this limit statement, we'll limit part, we'll take it in and E we will keep it here. So limit goes to the exponent because limit only applies to wherever the x is, right? Okay, so this will become tan x natural log of sin x. So that means we have to figure out this limit, and then we just put that limit as the power of. So let's do this separately. So what do we get? The limit as x approaches 0 from the positive side of tan x natural log of sin x can be written as limit as x approaches 0 from the positive sign of sin x by cos x natural log of sin x. Now remember, again we can split this limit statement to the numerator and denominator separately, and let's take the limit of the denominator because cos 0 is 1. Since cos 0 is 1, we can ignore it. So limit as x approaches 0, this becomes sin x natural log of sin x. So that is what we end up with. Can we do something with the sign? What we can do is we need to take it to the denominator. So let's take it. This is not limit. This is natural log of sin x. And if we have to take it to the denominator, we have to say 1 by sin x. Now, if you do the substitution, what happens? Sin 0 is 0. Natural log of 0 is minus infinity divided by. Again, sin x is 0. So 1 by this one will be plus or minus infinity. So we have an indeterminate form. Right? So that means we can apply the L'Hopital's rule here, which means we can differentiate the numerator and denominator. Okay, what I'll do is I'll do it here itself. So limit as x approaches 0 from the positive side. Now I'm going to differentiate the numerator and the denominator. This will become 1 by sin x times cos x divided by 1 by sin x. We have to differentiate. What do we get? We can write it as sin x to the power of minus 1. So that will be minus 1 by sin square. Okay. Okay, now let's simplify this as x approaches 0 from the positive side of cos x by sin x times reciprocal of this. So minus sin square x. 1 sin x and 1 of this gets cancelled, and we end up with limit as x approaches 0 from the positive side of cos x minus, let's take it here, and sin x. Now cos 0 is 1, sin 0 is 0. So which means this limit is 0. And this limit we put it here. So 3 times e to the power of the limit of this 0, which is nothing but 3 times 1, which is equal to 3. So 3 is the limit. Let's look at the 14th one. Limit as x approaches 0 from the positive side of x to the power of tan x. Okay, if we do the substitution, we get 0 to the power of 0. Tan 0 is 0. So indeterminate form. What we'll do is we will again bring the tan down. So how do we do that? we exponentiate then natural log of x to the power of tan. E and natural log cancel out and we get the original back. Okay. So now this can be written as x approaches 0 of e to the power of exponent, we can bring it down, natural log of x, right? And since this e is a constant, we take the limit in. So limit as x to the power 0 on the positive side of tan x natural log of x. Again, we just have to figure out the limit of this and put it as the exponent of e. So let's do that. Limit as x approaches 0 from the positive side of tan x natural log of x. If we do the direct substitution, we get 0, tan 0 is 0, natural log of 0 is minus infinity. So this is 0 times minus infinity. So again, an indeterminate. So what we will do is again make some changes to this. This actually we can write it as sin x by cos x, right? Sin x by cos x times natural log of x, right? Now again, as in the previous problem, we can take the limit of the numerator and denominator separately. So in the denominator we have cos x. So if we take it to the limit of 0, this becomes cos 0, which is 1. So which means we can ignore it. And we end up with sin x natural log of x. And now here, limit as x approaches 0. Here again, we are still in the same position, 0 times minus infinity. So we still don't have uh, a workable expression. So natural log of x remains as it is. And if we take it to the denominator, it becomes 1 by sin x, right? And now we will differentiate. Why? Because natural log of x 0 is minus infinity and 1 by 0 is again infinity, plus or minus. So it is in the indeterminate form. So we apply the L'Hopital's rule. So limit as x approaches 0 from the positive side, the derivative of natural log of x is 1 by x divided by, I'll put it in this form. And if we differentiate this, this can be written as sin x to the power of minus 1. So this becomes minus 1 by sine square, right? And now limit as x approaches 0 from the positive side, 1 by x times the reciprocal of this, sine square x. Which means we can split that sine square in this form, sin x by x times minus sin x. And now if we take the limit, we know that this is 1 times 0, which gives us 0. Now if this is 0, we can substitute it here. So we get e to the power of 0, which means the limit is 1. Okay, pretty interesting. Okay, 15th one. We have limit as x approaches 0 from the positive side of 4x to the power of 2x. Do direct substitution, you will notice that this will be 0 to the power of 0, an indeterminate form. So what do I do? Let's write it in this form. Or let's take it out. Limit as x approaches 0 from the positive side of x to the power of 2x. Now again, we have to bring this 2x down. So for limit as x approaches 0 from the positive side of e to the power of natural log of x to the power of 2x, which can be written as 4 times limit as x approaches 0 from the positive side of e to the power of 2x natural log of x, right? And now we can take the limit inward. So e to the power of limit goes up, limit as x approaches 0 of on the positive side of 2x natural log of x. So we figure out this limit and put it in the exponent. So limit as x approaches 0 from the positive side of 2x natural log of x. Do direct substitution, what do we get? We get 0 times minus infinity. So indeterminate. So let's write it as 2x, we'll take it down. So natural log of x by 1 by 2x. If we do that, what happens? This becomes minus infinity and 1 by 2x becomes infinity, right? So we have it in infinity by infinity form. So let's actually differentiate it by applying the L'Hopital's rule. So as x approaches 0 from the positive side of 1 by x divided by, and 1 by 2x, if we differentiate, we get 1 minus 1 by 2x square. Okay. And now let's take the reciprocal 1 by x times 2x square, and let's put the minus here. Here 1x and 1x gets cancelled, and we end up with limit as x approaches 0, the positive side of minus 2x, which will be 0. So if this is 0, we just substitute it here. 4 times e to the power of 0, which is equal to 4 times 1, which is 4. So 4 is the limit. 16th one. Limit as x approaches 0 from the positive side of 2 tan x to the power of sine x. Now you got the idea. We have to bring the sine x down. Because if we substitute it directly, what happens? Tan 0 is 0, sine 0 is 0. So we end up with 0 the power of 0 form, which is a indeterminate form. So let's rewrite this as 2 times limit as x approaches 0 from the positive side of e to the power of sine x natural log of tan. I've jumped one step, but you should be able to figure out this. Okay. Now we can see this is a constant, e is a constant. So we just have to figure out the limit as x approaches 0 of sine x natural log of tan x. That's what we have to figure out. Okay, so let's figure out that. Just like before, what we'll do is we will send from the positive side. Okay, we will send the sine x to the bottom. So natural log of tan x by 1 by sine x. So this becomes of the form minus infinity by plus or minus infinity. Okay, so it's a indeterminate form. So let's differentiate it, which means basically applying the L'Hopital's rule. So this will be 1 by tan x times sec square x divided by, okay, so this will be minus cos x by sine square x. We have to simplify this. Limit as x approaches 0 from the positive side of 1 by tan x is cot x sec square x minus cos x by sin square x is cot x times 1 by sine, because this is square. So 1 by sine. 1 by sine is going to be, let's keep it as it is, 1 by sine square x. Okay. So cot x and cot x gets cancelled, and we end up with limit as x approaches 0 from the positive side, where x is 1 by cos square x, right? And then divide by, we have minus 1 by sine square x. So limit as x approaches 0 from the positive side of 1 by cos square x times minus sine square x. And if we take the limit, what happens? Sine 0 is 0 and cos 0 is 1. So 0 by 1, which is 0. So which means here it actually take the limit. 2 times e to the power of 0, which is equal to 2 times 1, which is equal to 2, is the limit. Okay. 17th one. Limit as x approaches 0 from the positive side of 3x sine x. Direct substitution gives you 0 to the power of 0 form. Okay, so let's manipulate this 3 times limit as x approaches 0 from the positive side of e to the power of sine x natural log of x. Okay, so which means we have to figure out the limit of this. So limit as x approaches 0 or from the positive side of sine x natural log of x. And we know this how to do now. The more you practice, the more you remember the tricks of the trade, as they say. Natural log of x by 1 by sine x. So this will be what? Natural log of 0 is minus infinity, and this is going to be plus or minus infinity. So which means we can apply the L'Hopital's rule. Let's differentiate it. We get limit as x approaches 0, 1 by x divided by minus cos x by sine square x. And this, let's rewrite it as 1 by x times sine square x by cos x, and let's put the minus here. Now here's the trick. One of the sine x will bring it here above x times minus 1 by, not minus 1, one of the sine x is there. So minus sine x by cos x. So this, if we take the limit, is 1. And this is going to be 0 by 1. That is 0, which is equal to 0. So that means this will become 3 times e to the power of 0, which is equal to 3 times 1, which is, that is the limit. Limit as x approaches infinity of 4x to the power of 1 by x. If we take the limit directly, what do we get? In the denominator, we will have infinity, and 1 by infinity is 0. So this is one of the indeterminate forms. Okay, so that means we can't directly do it. So limit 4, let's take it out, as x approaches infinity of x to the power of 1 by x can be written as limit as x approaches infinity of what? E to the power of natural log of x, and 1 by x we can take it down, which means we have to take the limit of this only. So limit as x approaches infinity of 1 by x natural log of x. Natural log x goes to it goes to infinity, and this also goes to infinity. So which means we have infinity by infinity. So let's differentiate. So limit as x approaches infinity, let's apply the L'Hopital's rule. So natural log of x is 1 by x. No, let's say minus 1 by x. Let's differentiate this first. And natural log of x remains as it is. Plus, now 1 by x remains as it is, and we differentiate natural log of x. So we are left with as x approaches infinity of minus natural log of x by x square plus 1 by x square. So this becomes limit as x approaches infinity of minus natural log of x plus 1 by x square. So this again is going to be what? Minus infinity, but this minus will make it plus infinity. So infinity by infinity. So which means we apply the L'Hopital's rule once more. That means once more we differentiate. So minus 1 by x by 2x, which can be written as limit as x approaches infinity of minus 1 by 2x square. Now, if we take the limit now, minus 1 by infinity is going to be 0, which means here what will happen? 4 times e to the power of 0, which is equal to 4 times 1, which is equal to 4. So that is the limit. Wow, beautiful. Love it also. That's it. Bye.